AI advancements and you. Exploring the latest breakthroughs in artificial intelligence and their impact on our daily lives. Decoding AI, a beginner's guide.
Welcome to the show, Dr. Reed. AI feels like it's everywhere these days. Can you give our listeners a simple explanation of what exactly artificial intelligence is?
Absolutely, Alex. In simple terms, AI is about creating computer systems that can perform tasks that typically require human intelligence. This includes things like learning, problem solving, decision making, and understanding language.
So, it's not just robots taking over the world.
That's a common misconception. While robots are one application of AI, AI is much broader. It's the underlying intelligence behind many things we use daily, like recommendations on Netflix, spam filters in email, or even voice assistants on our phones.
That's fascinating. What are some of the most exciting recent breakthroughs in AI?
One major area is generative AI, models that can create new content, like text, images, or even music. We've seen amazing advancements in large language models capable of generating human-quality text and responding to complex prompts. Another exciting area is in healthcare, where AI is being used to assist in diagnosis, drug discovery, and personalized medicine.
Wow, that sounds incredibly impactful. What are some potential downsides or ethical concerns we should be aware of?
Absolutely. Bias in algorithms is a major concern. If the data used to train AI models is biased, the AI will inherit those biases, potentially leading to unfair or discriminatory outcomes. Another is the potential for job displacement as AI automates certain tasks. We need to carefully consider the ethical implications and develop responsible AI practices to mitigate these risks.
That's a crucial point. Dr. Reed, thank you for shedding light on this complex topic for us. Where can people learn more about AI?
There are many great online resources available, including websites like Google AI and open source AI communities. It's a field that's constantly evolving, so staying curious and engaged is key.
Thank you for being with us today, Dr. Reed.
Bayes' theorem decoded. Understanding Bayesian networks and their real-world applications in a simple way. Bayesian networks, making sense of uncertainty.
Welcome to the podcast, Dr. Carter. Can you explain Bayesian networks in a way that someone with no prior knowledge can grasp?
Absolutely. Alex, imagine you have a bunch of things that are related, like the weather, your mood, and whether you decide to go for a run. A Bayesian network shows how these things influence each other. It uses probabilities to show how likely one thing is given another. For example, it can show the probability of going for a run if it's sunny versus if it's raining.
So, it's all about probabilities and how things relate to each other. Can you give me a real-world example?
Sure. Think about spam filters. They use Bayesian networks. They look at things like the words used in an email, the sender's address, and so on, based on the probabilities of those things appearing in spam versus non-spam emails. It decides whether to mark it as spam. If an email has lots of words commonly found in spam, the probability of it being spam goes up.
That's really interesting. Are Bayesian networks used anywhere else?
Absolutely. They're used in medical diagnosis, predicting the likelihood of a disease based on symptoms. In finance, predicting market trends. In self-driving cars, making decisions based on sensor data. And even in recommending products based on user preferences. They're incredibly versatile.
So, They help us make better decisions in situations with uncertainty. It seems like a pretty powerful tool. Thanks for explaining it so clearly, Dr. Carter.
My pleasure, Alex. It's a fascinating field. Algorithms explained. Demystifying computer science concepts with simple explanations. Short job first and first come, first served.
Hi Dr. Chen. Thanks for joining me today. Let's talk about scheduling algorithms. Can you explain what first come, first served, FCFS, is in simple terms?
Sure, Alex. FCFS is exactly what it sounds like. Jobs are processed in the order they arrive. Think of a line at a coffee shop. Whoever's been waiting the longest gets served first.
Got it. So it's straightforward and easy to implement. What about its drawbacks?
Right. While simple, FCFS can be inefficient. Imagine a short task arriving after a very long one. The short task has to wait a long time, even though it could be finished quickly. This leads to a longer average waiting time for all jobs.
That makes sense. So that's where shortest job first, SJF, comes in, right?
Exactly. SJF prioritizes shorter jobs. It might seem intuitive. Finish the quick jobs first to get them out of the way and reduce average waiting time. The scheduler needs to know the duration of each job beforehand though.
So SJF is more efficient in terms of average waiting time. But it needs that advanced knowledge of job durations, which isn't always possible. Correct?
Precisely. In real-world scenarios, accurately predicting job length can be challenging. That's why FCFS, despite its potential inefficiencies, is often preferred for its simplicity and lack of needing that prediction.
So, it's a trade-off between simplicity and efficiency. Thanks for clarifying these concepts, Dr. Chen.
My pleasure, Alex. It's all about choosing the right algorithm for the job.